All right, your AI engineering final is coming up, and you've landed in exactly the right spot. We're not going to bore you with textbook cramming. Instead, we're going to do a super fast-paced review of the concepts you absolutely have to know to crush that exam. You ready?
I get it. You've covered a ton of ground, and it probably feels like a mountain of information. The pressure is definitely on. I mean, where do you even begin? Look, the secret here isn't just memorizing stuff. It's about getting that fingertip feel for how all these different pieces actually connect and work together. So, let's start from the top, the big picture.
Okay, first thing you've got to get straight in your head. This is not just some new flavor of software engineering. It's way more than that. AI engineering, it's a whole new discipline. And that's because we're not writing hard-coded rules for every little thing anymore. We're building systems that actually learn from data.
So, what exactly makes it so different? Let's break it down.
Okay, this is the absolute core idea you need to nail down. Think about it. Traditional software is deterministic. You write a rule if this, then that, and it always does the same thing. No surprises. But AI systems, they're probabilistic. They're all about data and models making educated guesses or predictions. So the heart of the system isn't just code anymore. It's the data, the model, and the code all dancing together.
And because these systems are so, well, different, you can't just wing it. That's a recipe for disaster. You need a plan, a blueprint, a structured, reliable way to build these things without pulling your hair out.
And that right there brings us to a super important topic for your exam. It's one thing to build a cool little demo, right? But it's a whole other challenge to build something that's actually profitable and reliable in the real world. So the big question is, how do you plan a project so it actually succeeds and you don't waste a ton of time and money? Well, you need a methodology.
And that methodology has a name, UMEP, the Unified Model Engineering Process. Now, this isn't just some fancy buzzword to throw around. It's a real, practical way to bring some engineering discipline to what can be a pretty chaotic development process. It gives you a roadmap, a structured set of steps you can follow and repeat.
So UMEP breaks down into three main phases. You've got inception, where you figure out the what and why. Then elaboration, where you design the solution. And finally, construction, where you actually build and ship it. But listen up, one of these is way more important than the others when it comes to success.
Okay, I need you to lean in for this one. This is a huge hint for your exam. You're definitely going to see it. The elaboration phase. This is where projects live or die. Seriously, this is your chance to really nail down the requirements, build little prototypes to see if your crazy ideas will actually work, and figure out all the risks before you're too deep in the weeds. The key takeaway is this. Spending time here in elaboration saves you from massive, expensive headaches and redesigns later on. You're basically de-risking the entire project before you've even started the heavy lifting of construction.
All right, so that's the process, but let's get to the fun part. What are we actually building? Let's peek inside the model's brain. Yeah, what is actually inside that little file you end up deploying?
So, at the core of pretty much all modern AI, you've got the Artificial Neural Network, or ANN. And just like the name says, it's inspired by the human brain. You have an input layer that takes in data, these hidden layers in the middle that do all the thinking, and an output layer that spits out the answer. It learns by tweaking the strength of the connections between all those layers.
So what's the actual food for these networks? For language models, it's not words, it's not characters, it's tokens. And this is a really important concept to get. The model doesn't see hello world. It sees a sequence of tokens. This is super clever because it lets the model handle words it's never seen before. Like it might break down a word like AI engineering into AI, a hyphen, and engineering. It gives the model so much more flexibility.
And this is how it all connects back to that file from your exam question. So what is the model learning? It's learning the perfect numbers for its parameters, or weights. These are millions, sometimes billions, of tiny numbers that represent all the patterns and knowledge it picked up from its training data. And that knowledge, all those numbers, is what's physically saved in that .pt file. When you deploy that file, you're literally deploying the model's trained brain.
Okay, so the model has a brain, and it's powerful. But here's the catch. It only knows what it was trained on. So how do we make it useful for today's problems? We have to give it two things: fresh context and tools to work with.
Just take a look at the training data for a big model like Llama 3. See that? Almost half of its training diet is math, reasoning, and code. And that is completely intentional. This kind of high-quality, structured data is what builds the model's core ability to reason. Once it has that, it can apply that reasoning skill to pretty much anything else. But there's a big problem. Pre-training happened in the past. The model doesn't know about last week's news, and it definitely doesn't know about your company's private documents. So this is maybe the most important question for any real-world AI application. How do we give the model up-to-date knowledge without having to retrain it all the time?
The first and most popular solution is a pattern called RAG. That's Retrieval Augmented Generation. And honestly, it's a total game changer. Here's how it works. Before the model even tries to answer your question, the system goes and retrieves relevant documents from a knowledge base. Then it stuffs that info right into the prompt along with your question. It's like giving the model an open book test. It has all the facts right there in front of it.
Okay, so if RAG is about knowing things, the next pattern, Agents, is about doing things. An agent can think, it can make a plan, and it can actually use external tools. We're talking about calling a search API, running a code interpreter, or querying a database. It gets a result back, looks at it, and decides what to do next. So let's be clear on the difference. RAG gives a model knowledge. An agent gives it power tools.
Okay, we've got our process, we've got our model, we've got patterns to make it smart. Now for the last piece of the puzzle, the part that makes it real. Deployment. How do you actually get this thing out into the world and into the hands of your users?
All right, this is basically a cheat sheet for one of your exam questions, so listen up. When you're deploying to the cloud, it really comes down to a checklist. First, make sure you have the right hardware, probably a GPU. Second, you containerize everything, the model, your code, all the dependencies. Third, and this is super important, you have to check the model's license to make sure you can actually use it for your project. After that, you upload your files, tell the system what code to run first, and finally, you test your endpoints and write some documentation. Seriously, just walk through those steps.
Phew! Okay, we've gone all the way from a basic idea to a deployed product. So for this last part, let's look ahead. Let's connect all these ideas and tackle a really cool, forward-thinking engineering problem.
So here it is, the big one, the question that ties everything together. You know the classic model view controller pattern, right? MVC. The controller is the bit of logic that takes user input and decides what to do. So, could an AI agent replace that controller, especially a small, fast language model running right on your phone, on the edge? Could an AI literally become the new brain of your app's logic?
Answering a question like that, well, that's not easy. It really forces you to understand what makes this field new. There's a great quote from Chip Huyen that says it all. The familiar and ease of use of many AI engineering techniques can mislead people into thinking there's nothing new to AI engineering. And she's spot on. It's so tempting to think you can just drop an LLM into an old system and call it a day, but you can't. You have to engineer the solution from the ground up.
So when you think about building that future, what's in your toolkit? Well, you're going to need things like inference optimization to make models run super fast on a device. You'll need agentic planning and function calling so the model can actually do things in the real world. And you'll need those small, efficient language models that can live on the edge. The future of software is becoming more and more intelligent, and it's moving from the cloud right into the palm of your hand. So the real question isn't just about the exam, it's are you ready to build it? Good luck!